so that's 13 pi over 6, is that now I want to like recycle that fraction. I created common denominators. I'm going to do it again. So now I'm going to do pi over 6 minus 12 pi over 6. So So then we get negative 11 pi over 6. So then what I'm going to do to these two coterminal angles to find two additional coterminal is I'm going to do the same thing again. I'm going to just add the 12 pi over 6 and subtract the 12 pi over 6 again. So 12 plus 13 is 25 pi over 6. And then negative 11 minus 12 is going to be negative 23 pi over 6. I'm gonna do the same thing here. So like I'm gonna add, sure. Like the last one, like this one, the 25 or the negative 23. Okay, so what I did to get from the 13 pi over 6 to 25 pi over 6 is I just added another rotation. Like I just added 12 pi over 6 again to get the 25. So like I had pi over 6 looks like this. Here's 13 pi over 6. And then I just went around again to get the 25 pi. Does that make sense, person in the chat? I always call my person who I'm talking to in the chat person in the chat. I don't know what Miss Weiss calls them. Hey, person in the chat, are you good now? Can you say yes or no? Cool, thank you. All right, so same thing here. I added one rotation. I'm going to do it again. People who are just joining us, yes, Mrs. Strauss is teaching you. Miss Weiss is not feeling well. I'm covering for her. Considering I'm going to teach this lesson 2 more times today, I'm more than qualified to teach it to you guys. I'm going to subtract my rotation. That gives me negative 7 pi over 4. I'm going to subtract it a second time. Like I can do this indefinitely. It's just like spinning around in a circle. Now I'm going to do it to pi over 3. Pi over 3 plus 2 pi over 1, 3, 3. Pi over 3 plus 6 pi over 3 would be 7 pi over 3. Plus another 6 would be 13 pi over 3. Now we'll do pi over 6 minus the rotation. And that gives us negative 5 pi over 3. And we'll go backwards again. And that would give us negative 11 pi over 3. Yeah, I know Canvas is having problems this morning. Hoping it'll clear up. Ladies and gentlemen, are there any questions on how we find coterminal angles in radians? Great. Either unmute yourself, ask out loud, or throw it in the chat. All right. So announcements for the day. You don't have any homework to submit. We're gonna, just kind of keep on keeping on this week, learning some new material, easing into trig. Hopefully you guys all got your packets. I got my packets. It was real exciting. See, I got my packets. You guys get your packets? It's exciting. Less notes to write. If you did not get your packets, I know Miss Weiss has posted an announcement. We're going to do one more run with Copy Plus. Please fill out the form. And yeah, I'm happy to try to answer any other questions that you would have asked her at this point. Okay. Today we are going to talk about using reference triangles. Move it over, Harry Potter. Using the reference triangle of an angle in standard position to evaluate a sine, cosine, or tangent value that is larger than 90 degrees. We are going to start abandoning the idea of slightly of opposite over hypotenuse as the only way to define sine. So if for some reason you don't have a packet, you need to write down that a reference angle, and I normally underline for my kids who don't have the packet exactly what they need to write down. A reference angle is the acute angle found between the terminal ray and the x-axis. It is very important to know that the reference angle is between the terminal ray and the x-axis. Okay. If you have an acute angle, it's its own reference angle. So here are some examples. Here I've got 130 degrees in standard position. Comes across, and this angle between the terminal ray and the x-axis is 50 degrees. It's important to note that I found that 50 degrees by doing 180 minus 130. The second example is 250 degrees. So I graphed 250. It falls in the third quadrant. And here's the angle between the terminal ray and the x-axis. Now, for the first one, I did 180 minus the angle. What arithmetic do you think I did to get 70? What a little piece of arithmetic did I do? Bravely unmute or throw it in the chat. What did I do to get the 70 degrees? Otherwise, Harry Potter's gonna have to answer, and that's awkward. If this is 180, 250 minus 180 gave us the 70 degrees. So that's for the third quadrant. Over here in the fourth quadrant, I graphed 320 degrees. 320 falls in the fourth quadrant. Here is my reference angle between the terminal ray and the x-axis. To find the reference angle in the fourth quadrant, I did 360 minus 320. Can everybody click yes on the participants bar so I know you are alive? I mean, I know Lauren's alive. I'm pretty sure Eugene didn't die in the last 3 seconds. But, like, are the rest of you alive? Kai, are you alive? Hit yes on the participants bar if you are alive. Layla, are you alive? Julian, are you alive? Maria, are you alive? Sophie, are you alive? Okay, someone's dead. That's not good. But at least we know they're clicking on something. All right. So this is what we are going to do. For every single problem, and if I were you, like these 4 directions, these are going to be the directions we're going to use legit for 2 weeks. So I would put a star around them. We are going to sketch every angle in standard position. We are going to find the reference angle. We are going to sketch the appropriate special right triangle. We are going to pay attention to the possibility of negative side lengths. And then we are going to find the exact value of each trig function. Hey, Lauren, just for pacing, are you writing are you writing all this down or doing a packet?
I'm writing it down, but I can also screenshot it and just like.
No, that's okay. You write it down. Give me like a thumbs up when you're ready. Because I really want you guys to have good notes on this. This is like important stuff, man. You can't just wave your magic wand and like get the answer.
Yep, I'm done.
Okay, so this is what I want everyone to do. I want everyone to pop open your chat. And I want you to type the number, but do not press enter. What quadrant does 120 fall in? Type what quadrant 120 falls in, but don't press enter yet. Everybody press enter. You guys suck. There. All right, well, what quadrant is that, Ryan? There we go. Ladies and gentlemen, this is 1, this is 2, this is 3. Now they're coming in. This is 4. It falls in the second quadrant. So we're going to go ahead and draw 120 in the second quadrant. We're going to draw a line from the terminal ray to the x-axis. I need everyone to calculate this reference angle that I marked in dark purple. I want you to calculate that reference angle, type it into the chat, but do not press enter. What is the reference angle for 120? Everyone press enter. Hey, oh, you direct messaged me. You guys were so cute. That's good. 60 degrees. Everybody who sent me 60 degrees is correct. So now we need to dig out our special right triangles. The hypotenuse on the 30, 60, 90 is 2. So that's going to be a 2. Opposite the 60 is the square root of 3. Adjacent to 60 is 1. But because this triangle is in an XY axis, this 1 goes to the left. And we're almost talking about like, what's this ordered pair right here? It's -1 up 3. So anytime we go to the left or we have to go down, it's going to be negative. All right, so now the question is, what is the sine of 120? So I'm going to look at my reference triangle, opposite over hypotenuse, √3/2. Step 1, sketch the angle in standard position. Step 2, find the reference angle. Step 3, draw the triangle, paying attention to negative sides. Last step, find the exact value of the trig function. And if you need to add here using the reference angle, you should add that, because some people are like, they want to use the one up here. We're always looking at the reference triangle or the reference angle. Go ahead and sketch number 2, cosine of 225. Send me, since you guys seem to like doing the direct message thing, send me, if you want, the quadrant, comma, the reference angle. Sketch the angle, send me the quadrant, comma, the reference angle. Good. All the answers that have been sent to me are correct. Good job, guys. Go ahead and sketch your triangle. All the answers that have been sent to me are correct. Go ahead and sketch your triangle. So 225, 0, 90, 180, if this is 270, 225 falls in the third quadrant. If this is 225, I have a tendency to write my angles on the end, like if it goes like this, because I don't want to junk up the middle of the picture. Like I need to write here. I don't want to put the 225 there. So let's see, if this is 180, so 180 plus, I'm going to take away 180 from 225, and I get 45 degrees. So good job, those of you who sent me 45. So if this is 45, I got to be careful. This is -1, -1, √2. Okay, make sure you have -1, -1, √2. The first -1 is because it goes left. The second -1 is because it goes down. The hypotenuse is not a coordinate, so it's always going to be positive. So go ahead and find the cosine of this reference angle. Let's see. Adjacent over hypotenuse. And I know that Miss Weiss probably talked about this. Why didn't I put the, okay, because we all, like, you mean like to overhear person? Because, good question, we always draw our reference angle between the terminal ray and the x-axis. Always to the x-axis. I'm glad you brought that up. That is a very common question. So now, adjacent over hypotenuse, I'm going to rationalize the denominator. I'm only going to do this once because, like, you guys probably did this on Thursday. Got -√2. √2 times √2 is √4. Square root of 4 is 2. Questions on number 2? Bravely out loud or privately in the chat. All right, same deal. Sketch 330 and send me the reference angle and the quadrant. Quadrant, comma, reference angle. Quadrant, comma, reference angle. That could be a good song. What do you think, Harry Potter? Be a hit? Good. Look at all these good answers. Whoa, 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 whoa. I'll give you a hint. If you should not have one of the reference angles we've already had before. So if you have 60 or 45, take another look. You are doing a good job. Ooh, that is a wiggly line. Okay, so here's my 330. That's not going to junk it up, so I'll put that in. I'm going to always draw my reference angle between the terminal ray and the x-axis. So, person who said -150. -150 would be like over here. Like this would be 150. That is way too big. A reference angle needs to be an acute angle between the terminal ray and the x-axis. So I'm looking for this angle right here. Okay, so I know that the whole circle makes 360 degrees, and if I subtract off the 330, I'm just left with 30 degrees. Now, I know opposite the 30 is 1, but it goes down. So -1. I'm just in a different color. Big blue. I know the hypotenuse is always 2. And this goes to the right, so it gets to be positive √3. Good. Thanks for letting everyone know it's 30. Some people might not have known. You got to get them on the bus. Are there any questions on the blue numbers? Why is it √3? Because this √3 is the side that's opposite 60 degrees. So remember our special right triangles opposite the 30. The 2 isn't negative because the hypotenuse is never negative. The hypotenuse is not a coordinate. Does that answer the why is it √3 and why isn't 2 negative? Cool. I don't want that 60 degree there because it might mess me up. So now I'm going to take the tangent of this reference angle. Opposite over adjacent. And I'm going to multiply by √3 over √3. And I've got -√3. 3 times 3 is 9. Square root of 9 is 3. Are there absolutely any questions on these three examples? All right, my wonderful 19 friends, can you give me a thumb vote? I don't know if this week does this or not. On the participants bar, can I get a thumbs up? I feel pretty good. We use the coffee cup for the thumbs to the side in my class. So thumbs up, I feel good. Coffee cup, I feel okay. Thumbs down, I feel bad. How do we feel with this? Just so I can get a read. Thumbs up, I feel good. Coffee cup, okay, good. I'm expecting a lot of coffee cups. I'm not going to ask you to do these on your own yet. I just wanted to get an idea. Now, my friends who are thumbs up, you are free to work ahead. Like if you're like, I really have, like, I feel like I'm getting the groove of these. It's definitely a rhythm. Feel free to work ahead. So the next three problems we're going to look at are going to be similar, but they twist. And the twist is they are going to involve, oh wait, there's more. Wait, I'm a big liar. There are three more down there. So what? Some of them are going to involve radian measure. So go ahead, sketch. Before we get to that, let's do one more with degrees. Let's sketch 210. And again, send me quadrant reference angle. If you need to like just get like a check, you don't have to, but if you're like Strauss, am I on the right track here? You can send me your quadrants and your reference angles. There we go. People are sending me some nice answers. Harry Potter, I'm so proud of them. This crazy lady just showed up to teach their math class and they're just rolling with it like a bunch of superstars. Okay, so everybody who sent me 210, 0, 90, 180, yep, 210 falls in the third quadrant. And again, I don't draw the arc because then it like yucks up the picture. So then I'm going to draw this to the x-axis. And if this is 180, 210 minus 180 is 30 degrees. So sometimes I put in like, I know this is 1, I know this is 2, I know this is root 3, but then I have to think I went left root 3 and I went down 1. So the cosine of 210, negative root 3 over 2. All right, so number 5 is pi over 6. I told my kids, some people can think in radians, some people have to convert them all the time. And I recommended that my students put on their note card, like their little summary sheet, that pi over 6 is 30 degrees, that pi over 4 is 45 degrees, that pi over 3 is 60 degrees. And that can help you convert between degrees and radians really fast. So this is just the sine of pi over 6. This is just the sine of 30 degrees. I don't really need to put this in standard position, although it's nice, because it's its own reference angle. So the sine of pi over 6 is just going to be 1/2. But here's what I mean about the converting. Like if you are not a radian thinker, if you're looking at 3 pi over 4 and you're like, I don't know what that is. I see that there are 3 pi over 4s. So real quick, 45 and 45 is 90, plus another 45 is what? Okay, I can think about 135. Like that makes sense to me. All right, so now 135. And you're totally allowed to convert these whenever you want. It's not going to be like a law. 45. So this goes back 1, up 1. That's still root 2. So the sine of 135, opposite, over adjacent is just going to be -1. Questions? Questions, concerns? All right, so now I got some that are in radians. So this is what I want you to do. I want you to work on 7, 8, 9. Do not go on to number 10 yet because it's weird and you'll be like, I am scared. So just do these 3. I'm going to give you a couple minutes to work. And this is kind of awkward because I don't know you. Some of you don't know me, but do your best. If you need help, unmute yourself or send me a message. Harry Potter and I will help you. Right, Harry Potter? He says right. So if you don't have the packet yet, did you already, I'm assuming you filled out the first form. If you filled out the first form, it should be on the way. I just got mine Saturday and I live like 3 blocks from the school. So I would say you're getting them soon. Which numbers you're doing? I want you to do 7, 8, 9. Wait on number 10 and 11 because they're tricky. If you want to convert them though, that would be good. So if you don't have the packet yet, I mean, you can just still write them down, work on them. Does anybody want me to like think aloud how I convert these to degrees? Okay, I will do that for you then. All right, so just as a reminder, the trig's a big unit, and we really encourage you, those of you who had us in Algebra 2 kind of know those summary sheets, they're handy dandy. Keep all your important information on those summary sheets. So I would keep on your summary sheet the following conversions. Then you can just take that coefficient of pi. Like here, I have 4 pi over 3s. So if I think about it this way, like I have 4 pi over 3s, I have 4 60 degrees. So it's like, this one's easier than the 45. 4 times 60 is 240. So I'm looking for the tangent of 240 degrees. All right. Got some silence on some questions I put in the chat, so I'm just going to go ahead and work through these. 240 falls in the third quadrant. It has a reference angle. Again, my reference angle needs to go to the x-axis of 60 degrees. I'm going to go -1, -√3, and 2. So the tangent is going to be opposite over adjacent, which is just going to be +√3. Then for cosine of 5 pi over 6, I know that pi over 6 is 30. So 5 pi over 6 is 5 times 30, which is going to be 150 degrees. That's going to fall in the second quadrant with a reference angle of 30. Opposite the 30 is 1, and that's positive because it goes up. Hypotenuse is 2. Adjacent side goes to the left, so it's going to be -√3. Cosine is adjacent over hypotenuse. 7 pi over 4. So pi over 4 is 45. Sure, go ahead. If I do 7 times 45, I get 315. So I'm really thinking about 315 degrees. 315 degrees falls in the fourth quadrant. Ooh, that's ugly. -45-degree reference angle. It goes to the right 1, it goes down 1, it has a hypotenuse of √2. The sign is opposite over adjacent. And at this point, anytime you guys write down -1 over √2, you guys should know it's just -√2 over 2. Like, because we've done that rationalizing so many times. Are there absolutely any questions on 7, 8, 9? Yes or no? Are there any questions on 7, 8, 9? Click them on the participants bar so I know you are alive. Do you have any questions on 7, 8, 9? Do the number on the side of the triangle change? So it changes based on which reference triangle you're using. If you're using 30, 60, 90, or if you're using 45, 45, 90. And also if you're using 30, 60, 90, you just have to remember, okay, well here, 30 degrees is my reference angle, 1 is opposite that, and the √3 is on the adjacent side. For number 7, 60 degrees was my reference triangle, so √3 was opposite and 1 was adjacent. Does that help, person? Any other questions? Apparently there's only 2 people paying attention to me right now. So let me just say, so Miss Weiss knows when she watches this recording later. Only Gabby and Gladys were paying attention, Miss Weiss. Sorry. I don't know about the rest of these fools. I don't know where they are. They could be ghosting. Whatever. That's on them. When we get to number 10, I want you to notice we have pi over 2. So remember I said, keep on your note card these little conversions. Another good conversion to know, have at your fingertips, is pi over 2. We should know that 90 degrees is pi over 2. So this is just asking us for the sine of 90 degrees. Cosine of pi, well, 180 is pi. So this is just asking us for the cosine of 180. And tangent of 3 pi over 2, well, 3 times pi over 2, 3 times 90, this is just the tangent of 270. What's special about these 3? These 3 are quadrantal angles. I'm going to write that down. That was one of our vocabulary words from Thursday. I can't spell. Okay. Quadrantal angles fall on the quadrant line. So for example, sine of 90 degrees is just right here. Like this is 90 degrees. So I'm not going to draw a reference triangle. If you have your packet, if you already got your packet, the very front cover of, who's got the packet? Just yes, hit yes, yes, I have the packet in front of me. Okay, if you look at the very front cover of the packet, I'm going to pull up the old flip chart. Look at the very front cover of the packet. In Algebra 2, and I'm going to pull it. There we go. Look right there on the very front cover. We're going to use that. So, clipboard. There. Oh, nope. Where'd it go? Oh, darn it. That is big. All right. So, if you don't have your packet yet, or you didn't order one because you're silly, go ahead and screenshot this now or write it down. All right. So we define sine as opposite over hypotenuse. In some situations in Algebra 2, we started using y over r. All right. Here, cosine can be x over r. Tangent can be y over x. We're going to use that to find the sine, cosine, and tangent of our quadrantal angles. I'm just going to neaten this up because I need to be not so sloppy, Strauss, and not red. So we're going to start talking about this idea of what's called a unit circle, or a circle that's got a radius of 1. So I'm just going to kind of throw a circle here. Close enough. It bugs me that it doesn't come out from the center. They have to do it from the corner. That's so dumb. Right. So if I have a circle here, I'm going to say that my circle has a radius of 1. All right. This is 1. So here's 90 degrees. All right. Right here at 90 degrees, this point is 0, 1. Everyone write that down. So here, this circle has a radius of 1. At 90 degrees, the x value is 0. The y value is 1. So if I do y over r, I'm going to have 1 over 1. and the sine of 90 is 1. Now you can kind of conceptually work this out, like if you're a thoughtful person and you think about 90 degrees, like here's 90 degrees. Opposite 90 is the hypotenuse. So if you did opposite over hypotenuse, you would have like hypotenuse over hypotenuse, which would just be 1. So the sine of 90 using this definition also is 1. Let's look at the cosine of 180. So again, the radius of our circle, we're going to say is 1. So this is the point 0, 1, but 180 is way over here, and it's 0, negative 1. This is x, this is y. Cosine is x over r, so x over r, well, I don't know why I just wrote r there, that was stupid. X over r. 0 over 1 is just going to be 0. Do you need a minute to write, or can I keep going? It's very hard with all the cameras off. Okay, keep going. So now tangent of 270, again, all my circles are going to have a radius of 1, because you could really make this the radius anything you want, and then it just comes out in the wash, because like think about it, if I'd made the radius 5 here, the y would be 5, it would be 5 over 5. So here, same thing, my radius is 1. 270 is right there. And the point down here at the end of my terminal ray that I'm going to use is 0, negative 1, x, y. So tangent is y over x. So y over x. What happens when I do y over x? I'm going to get undefined. I can't divide by 0. So I always like to remind my kids, if you have 0 divided by a constant, that's okay. But if you have a number divided by 0, that's a no. I don't know. I kind of like that. Are there any questions on these 3 quadrantals? If you are good on 10, 11, 12, go ahead and do 13, 14, 15. I'll give you like a 1-minute head start, and then I will start working on them. All right. So 2 pi is 360 degrees. Negative pi over 2 is negative 90 degrees. And negative pi is negative 180 degrees. So if I'm over here, wee, at 360, purple's a hard color to look at. I've got the ordered pair, right 1, up 0. So again, I probably want to put these on my note card. I know the R is always 1. Y over R is going to be 0 over 1, which is just 0. Negative 90 is going to be down here. The ordered pair will be 0, comma, negative 1. X, Y. Cosine is X over R. So again, we have 0 over 1, which is again 0. Negative 180, which is the same as positive 180. All right, my ordered pair is left 1, up 0. Tangent is Y over X. Y over X is going to be 0. All right. Questions? We have about 8 minutes left. This is what I would like you to do for the following 8 minutes. On the next page, I've got some angles. They are already graphed for you in standard position. I want you to work on, I actually wouldn't even say the odds, because like I think I like the evens better, honestly. Yeah, I think I like the evens better. I'm gonna tell my kids to do the evens. So go ahead and work on these. I'm gonna give you about 4 minutes to work on your own. Let me know if you need me to slide it down. Let me know if you need help with any of them or the answers. I'm just going to work through these for a couple minutes. You guys are generally non-responsive, so I don't know if I'm talking to anybody. I don't know, Harry Potter. I don't know. Just because kind of it's already drawn for me, I'm just going to draw the reference angle to the x-axis. It's going to be 45 degrees. I'm going to label it left 1, down 1, root 2. And opposite over hypotenuse would be negative 1 over root 2, which becomes 150 degrees. Here's my reference angle. It's 30. This is 1. This is negative root 3. Ooh, that's ugly. This is 2. So adjacent over hypotenuse. So 240. Here's my reference angle. It's 60 degrees. And tangent is opposite. Oops, forgot to make that negative. Opposite over adjacent, which is just going to be the square root of 3. We've got 150 here. Reference angle of 30 degrees. Opposite is up 1, goes left root 3. Hypotenuse is 2. Opposite over adjacent. Rationalize the denominator. I get negative root 3 over 3. So here, 225 has a reference angle of 45 degrees. Negative 1, root 2. Opposite over adjacent. And then the last one is sine of 0. So 0 degrees is right here. I want to note that that's 0, 1. I know that sine is y over r. R is always 1. So it's going to be 0 over 1, which is just 0. It's about 10 o'clock. Those of you who stuck with it, thank you very much. Ms. Weiss will see you hopefully on Thursday. You guys are free. You don't have any homework. If you're all caught up with your work, you are free to log off and say goodbye. I'm happy to answer any questions you may have about missing work, Canvas issues that we've had, etc.